All right. Sweet. Welcome, everyone. I'm Izzy. I do a variety of stuff at Hex: agent stuff, research stuff, eval stuff, data stuff. We're going to start off actually with a little bit of audience participation. I'm going to show you all a couple of tasks, or like you could think of them as evals, actually. And you are going to decide or vote or shout out which one of these three you think is going to be the hardest for a frontier AI model in 2025 to do. Number one, this is an open mathematical problem proposed by Paul Erdős, some genius mathematician like 30 years ago. Open, not resolved. I won't try and read it. Very complicated. That's number one. This is number two. This is an issue submitted to an open source astronomy library on GitHub, AstroPy, with some sort of incomprehensible wavelength problems. And this is a quick question that Olivia, my boss, slacked me this morning at 11 a.m. about our notebook agent data. ABC, holler it out. Which do you think is more challenging? A primed audience of data people who know how hard and persnickety and downright stupid data work can sometimes be. And it's kind of silly, but we found ourselves in this place where like little weird, finicky, strange data problems are harder for these amazing agents than literal unsolved math problems. Well, they're getting solved. That one was just solved like the other week by an AI. GPT-5, I think, so shout out to Sean. So yeah, models are getting really, really, really good at coding. These are some of the charts from the recent GPT 5.2 release. It's scoring like 80% on the Swebench verified data set, which is where that GitHub issue came from. Like 80% on these difficult real-world problems is pretty remarkable. And it's kind of this interesting thing where it's like, okay, you know, they can do 80% of our like difficult real-world software engineering tasks. Like, what does that mean for data work, for disposable software in the data app space? And allegedly, if you believe a different OpenAI report, they're also getting equally good at data analysis. So this is a report from the, I think, ChatGPT agent launch from maybe like February of this year. And they're reporting, you know, 90%, 86% on data analysis and modeling. And you're like, oh my gosh, like, they're here, they're taking our jobs. And I saw this and was like, oh my gosh, they're here, they're taking my job. And so I looked at the eval set, and this is literally one of the evals in the DSBench hard data analysis set. It's, your task is to build a model in an Excel spreadsheet that basically sorts and identifies the unique words that you can make using the letters finance. It's like a ridiculous competitive financial accounting benchmark that nobody has ever really looked up under the hood and they just use to evaluate. But there are some data benchmarks out there that are slightly more robust, and it does show. So this is the DABStep benchmark made by Adyen. And you can see that the reports, this is old from February, so it's on O3 Mini, kind of an old model, but it's still, you know, like 5, 6, 16%. It's much more robust, and this is like actually, I would argue, where models are right now. But even this set has a lot of problems. This is one of the DABStep example evals. It's like, what is the top country for fraud? It has a couple examples. Seems relatively reasonable. When we run this eval on every agent, no matter what model, it always gets it wrong, quote unquote. The models always say that the answer is the Netherlands, and the ground truth answer is that the answer is Belgium. And you're like, why is this the case? This is the case because, as you can see in this beautiful hex chart, the Netherlands has the highest absolute fraud volume, the most fraud, but the fraud rate is much higher in Belgium. And every model, from some quirk in their pre-training, prefers to report fraud volume instead of fraud rate, unless you tell them which you prefer. This is just a very ambiguous question. It's a bad eval, but I would argue that either way, this is like the answer that you want from an analytics agent, right? You want it to give you a chart that shows you both dimensions of the data, and then you want it to say, hey, you know, there are two potential answers to this. Here's all the information. Which would you prefer to follow up on, et cetera. And this is basically how we are thinking about building analytics agents. So I'm very much not benchmaxing on the DABStep benchmark, tempting as it may be, because I think a model optimized for that benchmark would actually perform worse than a model optimized on maybe saying, I don't know sometimes, or hey, here's 2 potential answers. And so a lot of what we do is thinking about how we can build a robust tool for data analytics that can operate on these kinds of problems. We've built 2 agents into the Hex product. One is a notebook agent that operates in a notebook environment and basically helps technical users do technical, complex data tasks. You can see here a user having a conversation with our notebook agent, and on the other side in the notebook, charts, artifacts are being created to support its analyses. We've also built an interface for non-technical users that actually, behind the scenes, uses almost all of the same things as the notebook agent, but packages it up into an interface you can access via Slack or via a conversational interface. And there's some interesting challenges there as well. I'm going to talk about a couple of the components that we had to contend with while we built these. When you build any agent, there's really 3 things that you need to handle. One is context, which is like everything the agent can gather about the environment. The other are the tools that you give it so that it can manipulate that environment and go off and maybe fetch more data into its context or manipulate the data in its context. And then the third is actually the result, which I think is maybe the most important part, and we'll talk about why in a moment. So challenge 1 that we faced with context is that context blows up in unusual ways in data environments. I don't know if you've used the Hex agent or if you've ever seen this, but you hit it, or you used to hit it, a lot more than you would in like ChatGPT or Claude. The answer of why is that data fundamentally has a more risky or like explosive compression or context pattern than, say, a programming task. So if you're not familiar with what a context window is, it's just like all the tokens you stuff into your conversation with a model, ChatGPT or Claude, and it kind of grows throughout your conversation. Eventually it hits a limit, and the conversation cannot continue unless you compact it or compress it or start over. And we were seeing in our conversations with our agent that this is like happening over and over and over again. Sometimes a user would say hi, and the conversation would immediately compress. We're like, oh my god, what is going on? The problem is that code, and like any text really, is very easy to semantically summarize and compress. So you can take a function and you don't even have to include the code of the function. You can basically have the doc string. It's very, very, very easy to just sort of semantically summarize this stuff for agents. It's not really as easy to do that with like a 100 million row data warehouse table. I'm sure you can run SQL queries against it to slice it and filter it and chunk it down, but basically we were seeing that context that our customers were bringing and putting into their notebooks, or that the agent was fetching back from databases, could sometimes be arbitrarily, unexpectedly large and have gigabytes of data that we were trying to stuff into the context window. We were basically shooting ourselves in the foot by trying to give the agent as many helpful ingredients as possible. The obvious answer here is to not give the agent everything. So instead of just stuffing everything in there, we set limits on the number of tokens that we can consume from each of these different contexts with priority. When we hit that budget, we actually just tell the agent that there's more stuff that it can't see, and we'll talk about tools in a moment. It can kind of go and fetch this dynamically and intelligently. And then, most importantly, instead of dumping the entire project and the entire table and everything into the context, we have a very interesting structured outline that we show the agent that lets it operate in this environment. And what you wind up here is like a really great agentic loop, which is what you want when you're building and operating an agent, where you kind of show it this summary, and the agent itself can decide when it wants to dive deeper and drill in for more information, exactly like a human analyst, essentially. So we're trying to kind of approximate a normal analyst flow instead of like stuffing massive amounts of information into our agent's brain. I'll just skip through that. The next challenge is about tool usage. And data environments are kind of fundamentally different than coding environments with regards to how tools are executed as well. You can think of a coding environment as being much more simple than the environment that we've given Hex. to operate in. I don't know if you've ever cracked open the graph tab of a Hex notebook, but we model our notebooks as reactive DAGs of all the cells and charts and Python code in a notebook so that we can operate the notebook much more efficiently and use it to build data apps and all that good stuff. And this is actually a very challenging thing to efficiently represent to the agent when you think of comparing it to, like a Git repo with a bunch of Python code in it in neat little files. The other interesting thing, well, there's a few interesting things, is that a lot of the operations that are cheap or like free in terms of latency for a coding agent are actually very, very expensive for a data agent. Like when you write a SQL query, you can't really know how long that might take to execute. It could take like an hour, it could take like 10 hours and crash the warehouse. Most queries don't do that, but most queries take, a couple seconds at least, which is expensive when you are thinking about these things. And agents need to wait for a lot of this stuff. And so if it wants to go and get more information, it has to actually really decide, is this worth it? The way that we solved this was by developing a very interesting proprietary format for how we represent the world the agent is operating into it. This is what a naive representation of a Jupyter notebook looks like when you tokenize it and send it off to an agent. This particular notebook is about 30,000 tokens, which isn't insane, but it's a pretty small notebook. And this is the same project in our proprietary NBD project context representation. It's about a tenth of the size. It's much more semantically meaningful. It's laid out in a very, very sort of clever way that makes the LLM able to reason about it at pretty much arbitrary scale we've seen. It has a couple different components. The first component is the summary. We have this kind of summary section of cells that gives it a kind of arbitrary amount of metadata about each of the cells in the notebook in a very compact format with these tags. So you can see that this notebook, or this cell has sort of the input, what it defines. You can see that some of these show what it's referencing, how long it took to run, what kind of output it has, et cetera. Then we have the relationships, which encode the DAG dependency branches flattened and normalized out by the symbol. And this is actually token inefficient. You could obviously think about how to make this more efficient. But through testing, we determined this was the best thing in incredibly large notebooks for allowing the agent to say, I want to trace the dependency of this variable and find that whole DAG branch without having to deal with the entire rest of a 500 cell notebook. That would overwhelm it. And this altogether pretty much enables the agent to operate in notebooks of arbitrary size, arbitrary complexity. It can put its blinders on, it gets a summary, and then it can put blinders on and reason about individual branches of the DAG. And we've given it tools to kind of go out and fetch slices of the project, which look pretty much exactly like the entire project representation, but they're this little sort of projection of just a slice of the project. And iteratively in that loop, the notebook agent constructs and reconstructs and kind of reformats and changes the context that it creates for itself about the world it operates in. And yeah, we've seen this scale pretty much to arbitrary complexity. And it's pretty remarkable, the night and day difference between how the agent used to operate in real world notebooks versus our demo ones, and how it operates now in the real world versus the demo, and it's pretty much at parity. I'll skip that too. The last challenge is by far the hardest and the most unsolved and fuzzy, about analytical judgment. We see a lot of interesting behavior. We're privileged by all of you and a bunch of other people that are sending us feedback every single day, and we use Hex a lot internally, and we see ridiculous stuff that the agent does. In this one, I think this is internal, where the agent is this is very concerning, because it's growth is looking great, and then all of a sudden it's just tanks. And it's no, it's Thanksgiving. Relax, Mr. Agent. Or 100% enterprise churn rate. Of course we don't have 100% enterprise churn rate. There's a problem here. And we see over and over and over again, although they are getting better at it, that these models have a very difficult time exercising what you would really think of as table stakes, intern or high school level analytical judgment. Part of the reason for this is that there really aren't good unit tests for data work, or maybe just tests at all, we saw basically with that eval that I showed you, that you can't really make these the same way you can for a coding test, where you can make a bunch of tests, and it's did the agent do it? Does it pass the test now? And you can kind of train on that and improve and improve. There isn't really a harness for that kind of improvement, because the answers are so fuzzy and ambiguous and preferential and situational. The way that we've come up with solving this is kind of like a cop-out a little bit, but I think it's better for all of you, the users. We are actually talking a lot with Anthropic and OpenAI about these problems and how to make models more analytical, and GPT 5.2, I don't know where Sean is like significantly better at complex data science and making these kinds of judgments than any model we've seen before. But I still think that for a very long time, the right answer here is going to be to give data teams like very powerful observability and curation tools, basically like exactly what Olga was saying, and inserting humans into the loop here and giving them the new interfaces and observability into these workflows to catch when the agent is saying that there's 100% enterprise churn and add context to kind of redirect or endorse a different data set or curate something slightly differently so it doesn't make that mistake again. This is basically just a broader version of that same loop where you kind of get this beautiful virtuous cycle. The data team is curating content as they work in Hex. Users are self-serving in Hex and kind of like getting right answers, and they're getting some wrong answers too, but those wrong answers or like novel questions, I guess you could reframe wrong answers as, there's like complex, difficult things to answer, are getting looked at by the data team and investigated and put back into context, and the cycle gets smarter and smarter and smarter. And so I think that like you can sort of think of it futuristically as like all of this lets the models get smarter and smarter and smarter, but it's kind of like the human model data team partnership just becomes smarter and smarter and smarter, and the wheel keeps spinning. That's what we're building. I don't think we have time for questions, but I'm happy to answer any questions if you come find me or look me up or something. And while we're mingling, there's a little demo zone over there where you can go and ask our salespeople questions about Hex or make it dance for you. I think that's it. Thanks, everyone.